Hello everyone, my name is Vidit and today I am excited to present my solution for the Atlas Observability Challenge 2025. The scenario I was given highlights that debugging is slow and inefficient due to outdated logs making the process highly manual. Whenever an issue arises in production, we often have to rely on senior engineers to solve it, causing delays and inefficiencies. I would like to highlight two primary issues that often lead to faulty APIs. First is high server load and lack of scaling. If the CPU and memory usage spike due to high server load, then there is no proper scaling mechanism in place. Even a well-optimized API can fail. Inefficient API design and database bottleneck. Poorly written APIs, especially those with long database query times, increase the latency and error rates. To tackle these challenges, I am proposing a real-time observability through Insight dashboard and visual analytics. By leveraging beautiful data-driven charts generated from key system metrics, ensuring quicker debugging and smoother operations. To address this, as a platform engineering intern, I have designed a system architecture that enhances the observability and accelerates debugging. Let's understand the flow. When the user make a request on our backend server, user interact with the application but their request don't hit the backend directly. Instead, it first passes through an ALB, which is application load balancer, which smartly distributes the traffic across multiple instances. Behind the scenes, the virtual private cloud (VPC) keeps backend services isolated from the public internet, ensuring security. Any outbound request, like calling external APIs, go through a NAT gateway, controlling traffic without exposing the internal infrastructure. For container orchestration, I am using Amazon Elastic Kubernetes Service, which is EKS. For the sake of simplicity, I have shown one master node which ensures every service run optimally, and three worker nodes handle requests, scale automatically, and self-heal in case of failures. To ensure the robust observability and real-time monitoring, I have divided the observability stack into two components. First is metrics and logs collection, which include Grafana, Prometheus, Loki, OpenTelemetry, and Elasticsearch. Grafana provides a real-time dashboard for visualizing logs and metrics. Loki is lightweight, cost-effective log aggregation tool, making log analysis seamless. OpenTelemetry captures and traces API requests across the system, helping identifying the bottlenecks. Elasticsearch is used for log storage and querying, helps drill down into logs efficiently. Second is alert management. For that, I have used PagerDuty, which is used for real-time alerting using incident response, and it provides very good on-call support, ensuring quick resolution of critical issues. Speed and efficiency matters, so we have built layers of optimization. For example, Redis, I have used Redis, which caches frequently accessed data, reducing the load times. PostgreSQL manages the structured data reliably at large scale, which is really good and reliable for scalability. Apache Cassandra stores metadata with high availability. I have used Vault, which secures and stores credentials and environment variables. Kafka processes events asynchronously, reducing the API response time. And Kong API Gateway ensures the secure and efficient API traffic management. Now let's see this architecture for a developer's perspective. Developers push the code to GitHub, triggering an automated CI/CD pipeline. When a pull request is raised, it runs linting, security checks, and other type of test. If approved and merged in the main branch, a new Docker image is built and deployed via AWS Code Deploy agent. And if everything goes well, the deployment is successful. And if something fails, a rollback mechanism restores the last stable version. You might be wondering why this stack over others for observability. I selected this stack because they provide cost-efficient, scalable, and real-time observability without vendor lock-in, which is one of the greatest advantage for using this stack. Loki eliminates expensive log indexing, unlike Datadog and Splunk, which reduces the storage cost significantly. Prometheus efficiently scrapes time series data from Kubernetes, ensuring seamless scaling as compared to heavier tools like New Relic and Datadog. Elasticsearch enables deep log analysis and filtering, and Grafana offers fully customizable open source monitoring dashboard, unlike proprietary tools like New Relic, Datadog that restricts this flexibility. OpenTelemetry provides vendor neutral tracing, giving complete visibility into API request and system bottlenecks. So overall, using an open source, completely open source tech stack over others is really useful because it is really lightweight, fast, and easy to deploy and maintain. Now let me walk you through the dashboard that I prepared on Grafana for monitoring and observability. So as you can see on my screen, this is a setup of basic Node.js application, which has been dockerized with the help of Docker. And I have made this Docker file, and this is a Docker compose.yaml file, which is responsible for running all the observability stack. Let me show you all the Docker processes that are running right now. Yeah, so as you can see, these all are the processes that are running right now. Let us go on to the dashboard directly. And this is the dashboard for measuring all the key matrices that are required to find the faulty API in our backend system. So as you can see, this metrics, so basically key metrics which are required to check whether an API is faulty or not is, firstly we check average response time by an API, and as we can see that the average response time for the faulty API and the slow API is very large, like 3 seconds and 750 microseconds. So as you can see, these two APIs have high response time, which is a red flag. Other than that, we have to check for latency, and it can be checked using the response time by endpoint, P95 metrics. And again, the /API/slow route is returning very slow responses, and we can check requests per second for each API route, and we can see that the number of requests each API route is getting through this metrics. And these are all the total errors of type invalid data that we are getting, and the total error rate is 24.34%, which is quite high. And so these are the types of error that we are getting in the last 5 minutes. And to get the specific route which is generating the error, we can see that /API/faulty route is generating many errors in the last 5 minutes. And also to confirm that this route is faulty, we can check for the logs. And as we can see in this log, there are many errors generated, and to confirm that it is generated by that faulty route, we can expand and see which API route is generating all these errors. And we can clearly see that /API/faulty route is generating these errors. So by this we can conclude that this API is faulty. And this is endpoint performance summary, which gives average response time, error rates. Other than that, we can also measure the native metrics, which are like CPU usage, memory usage, and event loop latency. From this, we can see that when a faulty API is hit, we can see that the CPU usage rise abruptly. And also the time spent on CPU is also very high. And to get the detailed logs, we can check it in our logs section. So as you can see, these are all the logs that we are getting. As I told before, /API/faulty is throwing the error log. So by this we can confirm that this API needs attention, and if we have to make this API again. This is all from my side. Thank you very much.